So one more practice problem. You might recognize this function. We have a function f of x. It's defined in terms of a constant, an unknown constant called k. All we know is k is positive. But we can still take this derivative. Our first job is to find f prime and f double prime. So f prime, neither of these is going to require the chain rule. Let's get the whiteboard here. So f prime of x, k times x to the 1/2. The derivative is going to be 1/2 k x to the -1/2 minus the derivative of natural log of x is 1 over x. So that's my first derivative. My second derivative, f double prime of x. I have a 1/2 and a k that are constant multipliers. I'm going to take the new exponent down to multiply to the front, so that's going to be -1/2. It's going to multiply the 1/2 and the k that are already there. That's going to give negative k over 4. X to the new exponent is 1 less than the old exponent, minus 3/2. I'm going to think of this minus 1 over x as minus x to the -1. So when I take its derivative, this was subtraction. I'll write that 1 over x equals x to the -1. The old exponent's going to come to the front to multiply, and my x is going to get raised to the next smaller exponent. So I might find it convenient to simplify this expression. Remember, you have no obligation to. This is going to be negative k over 4 times x to the 3/2 is the square root of x cubed. So the fact that it's negative means it's in the denominator. Square root of x cubed. I'm going to have minus a -1 times, so I'm going to add x to the -2 is the same as 1 over x squared. Did you have to do that? No, I did that just in case you did it and you wanted to check your work. So now here's our interesting question, our new question. For what value of the constant k does f have a critical point at x equals 1? So when does a function have a critical point? When f prime equals 0 or f prime is undefined. So notice that the only time our f prime, let's look back up here. Here's f prime. F prime is undefined when x is 0, because I'm going to have this, I would have a 0 in the denominator. Same here, I would have a 0 inside the radical, which is in the denominator. So I can't let x equal 0, but check this out. The original function f was only defined for x's that were greater than 0. So I don't even have to worry about thinking about f prime being evaluated at any number that is 0 or less. So 0 is off the table for being the location of a critical point because it wasn't even a point in the domain of the original function. So the only other point I'm interested in is any x value that would make f prime equal to 0. So this is the equation I want to solve. F prime of x equals 0. So that's what I'm going to do. I have this one other piece of information. When x equals 1. So I'm going to try to figure out what k is going to be so that when x is 1, my f prime of x will be 0. So I'm going to write this equation, f prime of x equals 0. So 0 equals 1/2 k times x to the -1/2 minus 1 over x. Now I'm going to let x equal 1, and I'm going to try to figure out what k is. So 0 is 1/2 k times x to the -1/2 is 1 over the square root of x, but I'm going to let x be 1, minus 1 over 1. So now I have 0 equals 1/2 k. Didn't I say I was going to let that be 1? This is 1. Minus 1. Think about adding 1 to both sides. I'm going to get 1 equals half of k, so k must equal 2. My function f of x has a critical point when x equals 1 if k is equal to 2.